from our notes.
Sorry.
So, and our notes actually have a little review in them also, so we'll be, we may not get through all this today, but we'll see. All right, so we're on page 23 of our notes, number 10. And it is a little bit different, and I need somebody to tell me why it's different. What is different about number 10? Look back at the previous problems that we've been doing. What? The problem number 10 on page 23 is an inequality, just like we've been doing. But it has a 4 instead of a 0. And guys, when we do an inequality, we need 0. Okay? So, here's how we're going to handle this. And you're not going to like it because you'll have a different idea, but your idea won't work. So how we handle it is like this. Bring that 4 over to the other side. Now I think of it as 4 over 1, but I'm going to subtract that 4 over here to this side. Now I have my 0. Okay, you all right with that? Now, let's get a common denominator so that we don't have two different fractions, right? We'll get a common denominator. What will our common denominator be? X minus 3. This one's good. This one's going to need an x minus 3 in order to make it match. But of course, if I put an x minus 3 in the bottom, I have to put an x minus 3 in the top also, right? Now it's an inequality. The rules are a little different in an inequality. As soon as I get my common denominator, I'm going to write one fraction. One fraction now. I'm going to put these two together. They have the same denominator, so I'm going to write one giant fraction with that denominator. The numerator will be x plus 2 minus 4x minus 3. So I wrote down all that as one numerator over my common denominator. This is how we have to do it since it's an inequality. On the quiz you just took, it was an equation, right? Equals? And in an equals, you're allowed to ditch the denominator. In an inequality, you're not. You have to keep it. So this is where I'm at. Any thoughts on where I might go from here? The top. So the top is going to be x plus 2. Now be very careful. This is going to be minus 4x plus 12. And then I can combine even more, negative 3x plus 14 over x minus 3. Are you keeping up with me? Now, every time we have an inequality, we have a number line. And this number line is going to have 2 dots on it. Would you guess that one of the dots is going to be at 3? The other one is hard to tell. So if you can't, like this I can eyeball and say, okay, I'm going to have a dot at 3. If you can't eyeball it, set it equal to 0 and solve it. So where is that dot going to be? Positive 14 thirds. And how did I do that? I simply set it equal to 0 and solved it. What is the mixed number for 14 thirds? 4 and 2 thirds? Now why did I do that? Well, because I have to put it on my number line, and I have 3 and 4 and 2 thirds. So would you agree that they're going to go on in this order? Like that? pick a number. What number do you want to try?
6.
2?
Yep.
2's out here. You pick 2, remember it's out here. 2's over here. So if I put in 2, my numerator is 8. 3 times 2 is 6. Negative 6 plus 14. And my denominator is negative 1. Is 8 over negative 1 less than 0? Yes, it is, Naz, you're right. So I'm going to shade here, and then I won't shade here, and I will shade here. How's come I can alternate? Because there's no parentheses squared. Remember, you can always alternate unless you have an abnormal problem. You have to square it. So my answer, oh, wait a second. I'm surprised you guys let me get this far. What about my dots? Should my dots be colored in? Except what? What did we learn the other day? Remember that? Denominator dots are always open. Why are denominator dots open? Because the denominator can never equal 0. So I'm going to close in the 14/3, but I'm going to have to leave the 3 open because it's a denominator. Right? Now I'm ready to write my answer. So I have negative infinity to 3 and 14/3 to infinity. These are the hardest problems in this unit. Not really hard, just lots of stuff to keep track of. Alright, are we ready to start the next one? Alright, step 1. Notice that's a 2. Not good. So what's going to be my first step? Subtract it over. So 3x plus 1 over x minus 1. Subtracting minus 2. Now what? Okay, what do we do over here? Get the same denominator. So the same denominator will be x minus 1. Then what did we do? We wrote one fraction. And the denominator of the fraction is x minus 1. That's your common denominator. And then you have all of that on the top. So 3x plus 1 minus 2, x minus 1. Right? And then what? Yep, we're going to clean up the top. So, carefully, 3x plus 1 minus 2x plus 2. And then do our stuff. So that's going to be, oh, that one works out nice. Is that just x plus 3? Is that okay? So then I go to my number line, and where are my dots going to be? I'm going to have 2 of them. These are easy. One's at -3 and one is at 1. And they are open, both of them. And now what do I do?
Pick a point.
Pick a point. What do you want to pick?
2.
2. 2's out here this time. You gotta pay attention to where your number is that you pick, because that's where you're gonna shade or not shade. So if we put in 2, what do we get? If we put in 2, we get 5 over 1. Is that bigger than 0? So I'm going to shade out there. And then not, and yes. Bless you. So negative infinity to negative 3 in union with 1 to infinity. Now we're going to practice some more of those. But do you have any questions about the steps that we went through to do that? Okay. All right, the last thing in this little unit are some word problems, and 2 kinds, and 1 kind we've already done. So look at problem number 1. Have we done this before? Yep, who remembers? What's our strategy when we have one of these problems where we're mixing stuff together? Oh my gosh, we have a little formula. No one remembers it? Amount times percent. Yes, Pam. Amount times percent plus amount times percent equals amount times percent. You guys remember doing these. Oh my goodness gracious. Here they are again. Let's put our percentages in. We have 12%. We have 15%.
Oh.
And we're going to end up with 14%. Remember this? How much? What did we do with that? All these problems start with that. How much? What do we do with that? Put X right here. Isn't that how much? I don't know. Call it X. Needs to be added to 5 gallons of the 15. The 5 and the 15 go together. X plus 5. Very, very good, Willow. Because why? This amount plus this amount has to add up to that amount. That's what's happening in the problem. So these 2 added together. Sometimes I write that 5 plus X. It doesn't matter. X plus 5, 5 plus X doesn't matter. All right, now we solve. So 0.12X plus, we're going to multiply these together. You got a calculator. And then this is a distribute. So 0.14X plus 0.7. Hopefully my math is okay. And then we just solve like a regular equation. So I'll subtract this. This is one place where you 2 really have to stay on your toes. What do I get when I subtract 0.14 minus 0.12? 0.02, yeah, that's right. That's 0.02. Remember, you have a calculator, so if you're at all wondering, type it in. And I'll subtract the 0.7, and the same thing's going to happen. It's going to be 0.05. And I got, was it gallons? 2.5 gallons. We always label our answers when we have a word problem. And when I divide it by 0.02, I got 2.5 or 5 halves gallons. Okay? All right, we got another one. Problem number 2 is exactly the same. Would you agree with that? Exactly the same? So I'm going to have my setup. times percent plus amount times percent equals amount times percent, all right? What are our percentages this time? 54 and 0.84 and 60. This one is worded a little bit differently. 8 cups of 54. So aren't we going to put the 8 right here? The 8 goes with the 54. That's different. Needs to be mixed with some 84%. So we'll put an X there with the 84. Rereading. And then what are we going to end up with? If we mix 8 plus X, we're going to end up with 8 plus X. I don't know. What's 54 times 8? 4.32 plus 0.84X equals remember, you always have one distributive in these problems, so make sure you're doing your distributive property. We're going to move some stuff around here. We're going to solve this equation. And get all the X's on the same side. All the numbers on the other side. Did you get 2 cups? What do you think? Is that all right with everybody? All right, now when you read problem 3, now this is a different one. This is different. Can you just, when you read it, it's just different, right? But there's a little, like, setup formula type thing for these problems too. The idea in these problems is one person is doing a job, in a certain amount of time. Another person can do the same job in a certain amount of time. But if they work together, obviously, they can do it in less time. They can get the job done in less time. The setup for those kinds of problems is 1 over the first guy's time alone plus 1 over the second guy's time alone, and that will equal 1 over their time together. So every time we have one of these problems where we have multiple people doing a job, we're going to set it up like this. So Danielle can do her math homework in 4 hours. 1 over 4. If Zach helps her, it takes them 3 hours. All right, now be careful. Where does that go? What? That's together, isn't it? Isn't that if Zach helps her, it takes them 3 hours? And then the question is, how long is Zach alone? So 1 over X. Now this is an easier one than you had on your quiz, but this is the same kind of equation you had on your quiz. What are you going to want to do? Get all the denominators the same? So what's going to be our common denominator? 12, not 4x, it's going to have to be 12x. They all have to match, right? So we're going to make all of them 12x. So this one's going to get times by 3x. This one's gonna get times by 12, and this one by 4x. Does that look okay to everybody? And it's an equation, so you're allowed to get rid of the denominator. So it looks like I have 3x plus 12 equal to 4x. That's a times in there, 1 times 3 and 1 times 4. So how long does it take Zach by himself? Looks like 12 hours. Right? We subtract 3x from both sides, solve that equation. Is that okay? All right, see if you can set up the next one. I think these are pretty easy to set up. So remember, your strategy is 1 over alone plus 1 over alone equals 1 over together. So go ahead and see if you can set up problem number 4. What do you got, Suresh? What's your equation look like? Okay, what do the rest of you think? That look okay? Thumbs up? All right, what's our common denominator? What? 24x could be a common denominator. Did anybody try 48x?
Yeah.
That's fine too. Remember, there are lots of common denominators, so you just get one. 24 would be the smallest one, but 48 will work. I'll go ahead and use 24. So I gotta multiply this one by 3x, this one by 4x, and this one by 24. Now, before you start panicking, if you got a different common denominator, your equation looks different, but your answer will be the same. You should come up with 24/7 hours. You may have gotten 48 14ths, which reduces to 24/7. You are allowed to use whatever common denominator pops into your head, okay? So there's nothing wrong with using 48x. You have to have an x. So you get 48 over 14, but then you reduce that, because they're both divisible by 2, and you get 24/7. Is everybody okay with that? All right, let's see if we can wrap up this quick review at the bottom. It has a couple of those word problems. Let's do those first, just for a little bit of extra practice. So let's skip down and do number 3. Amelia can paint a room with Aaron. Seth, what do you think that equation for number 3 down at the bottom of the page is going to look like?
That'd be 1 over 4 plus 1 over x.
Equals 1 over 1. What do you guys think? I think he's right. I think he's right. What's our common denominator? 4x. So this needs an x. This needs a 4. And this needs a 4 and an x. Remember, all the denominators have to match. X x plus 4 equals 4x. Remember, that's times. Did you get 4/3 hours? Those are easy. 1 over alone plus 1 over alone equals 1 over together. All right, how about number 4? Another word problem. What is our setup? Read number 4. What is our setup for problem 4? Amount times percent. All right, so let's see if we can get this one set up. Our percentages are 16, and watch it, 2% is what what decimal? 0.02, yeah, don't be careless, 0.02, and then 10%. What are you gonna put in your amount parentheses? X, 9 quarts,
X plus 9.
and X plus 9. Beautiful. Everybody okay with that? All right, here we go, 0.16x plus, I'm gonna multiply those, I can use my calculator. No reason to miss it, I can use my calculator. And then be really, really careful, when you subtract 0.10x, what do you get over here? 0.06. Not 6 or 0.6, it's 0.06. I'm going to subtract that over. I got 12 quarts, but I'm going to let you guys, the calculators, double check that. 0.9 minus 0.18. Okay? All right, let's jump up and we'll do number 9, or number 1 and 2. They are review problems. This will be the first page of your test, or one of the pages. It'll be a whole page on the test. A problem like number 1 in the review. So, you probably will need to get out another sheet of paper. I don't know that you can get all this squeezed in there. If you can, fine, I don't care. But your job is to sketch it and label everything. So what are we looking to label? What are the things that are going to be in my picture? Holes, vertical asymptote, horizontal asymptote, X and Y intercepts. I'm on my notes, right down here, problem number 1. We just did 3 and 4. Now I'm doing number 1. All right, so how do we start? Factor. Can anyone factor the top?
Plus 4.
Plus 4, plus 3? Perfect. How about the bottom? Difference of squares, minus 4 plus 4? Now we can cancel. And we are actually going to be graphing this, which is very simple. Hopefully your test question's that easy. Okay? Now, tell me about the stuff. I need to draw a picture. I got my work down there. So tell me what is going to go into my picture. There's my vertical asymptote. X equals 4. How do I know that? Because vertical asymptotes come from the denominator. Horizontal asymptote is gonna be y equals 1, because y, box it, x over x. Okay. What else? What?
X-intercept.
My x-intercept is going to be -3. Why is that? How do I know my x-intercept is -3?
Set it equal
Because
to
they come out of the numerator.
Yep.
And if you set your numerator equal to 0, you get -3. That's where x-intercepts come from. Nice work. What else?
y-intercepts -3/4.
Y-intercepts -3/4 because y-intercepts happen when you put 0 in for x. You got everything but one thing. What do we not have in here?
The whole.
The whole. It's easy to forget. Remember, the minute you cancel, you are gonna have a hole in your picture. And the x coordinate of the hole will be -4. Because that's what you canceled out.
Who again?
Mr. McGinley, I stepped in your room the other day and I walked out.
Good.
Okay, did you find the y coordinate? What did you get for your y coordinate?
0.
No, when we plug in -4, we have -4 plus 3 over -4 minus 4. 1 over no, it would be positive. It'd be -1 over -8, which is 1/8. So -4, 1/8. Can you see a picture? Is that okay with everybody? We're gonna do one more, and we'll be done with this. Homework's due Wednesday, 2.8. But let's do this last review problem. Before I erase all this, does anybody have a question about that sketch? All right, let's sketch the last one, number 2. Alright, so you're sitting there, this could be a test question, it will be a test question. It will be a test question like this. You're sitting there thinking, alright, I gotta do some stuff. What occurs to you to do?
Take out a 2.
Take out a 2 from the top. I think that's a great idea. Alright. Now what?
Factor.
And how does the top factor? Please keep the 2. Keep the 2. Factor this. How does that factor?
X minus 2, X minus 1.
Minus 2 minus 1. And how about the bottom? X
5 minus 1.
plus 5 minus 1.
Cancel out
These will cancel. And now I know that I am going to actually graph 2x minus 2 over x plus 5. Alright, so let's get some stuff in the picture here. So here we go. This is what you're looking at. Look at this right here now.
vertical asymptote.
vertical asymptote at x equals -5. Please don't just sit there and write this down. Does everybody see why we have a vertical asymptote at x equals -5? What else do we have?
Horizontal at 2.
We have a horizontal asymptote at 2, y equals 2. Because we boxed in 2x over x. Are we gonna have a hole? Yep, and it's gonna be where x is 1. So if I put in 1, I get 2 times -1 over 6. -1/3. So 1 comma -1/3. Alrighty. Do I have an x-intercept? Set your numerator equal to 0 and solve it. X equals 2.
Y.
And, yeah, y-intercept.
Y equals 2/5. Right again. I got 4/5.
If I put a 0 in, I'm gonna get -4 over 5. I think it's -4/5. Does that look right?
Yeah.
If I put 0 in. Is that enough for you to see the picture?
Yep.
Be careful. Don't forget this piece, right? We gotta have 2 pieces to the picture. Okay? Alright, so your homework's due on Wednesday, and in our next class, which I think is Wednesday, we will start the practice test. Okay? Everybody good with everything?